Hey peoples. So this video is about very simple series or simple parallel circuits. That means they're not mixed, it's just resistors in series or resistors in parallel. And we're going to figure out as much as we can about each one. So let's do series first. I'm just making up a circuit really quick. We'll go with one here, and one here. So 3 resistors. We'll call this 5 ohms, we'll call this 15 ohms, and we'll call this 10 ohms. Okay. Now, we're going to answer a bunch of questions. I'm going to put a voltmeter here. The voltmeter always goes in parallel around the resistor. I'm going to say that the voltage on this puppy is 10 volts. How about that? So this reads 10 volts. We're going to address a bunch of questions. Okay, we want to know, one, the current coming from the source, the current from every resistor, so it'd be I5, I15, and I10. We want to know the total resistance of our circuit. We want to know the voltage on each resistor, so V4, or 15, sorry, V10. We want to know which one was the most powerful. And we want to know, what is that power? What is that power? All right. So first things first, I don't know if we need to really address everything in terms of a question. A lot of people just do the work on the circuit right away. What I mean by that is you should be able to tell that if the voltage is 10 and the resistance is 5 for the 5 ohm resistor, well, you should be able to quickly figure out the current, which is just V over R, which is 2 amps. That was pretty easy. And you should also know, and if you don't, you should have your series parallel notes out. You should know that in series, the current is the same everywhere. So that means there's 2 amps on the 15 and 2 amps on the 10. Now we know the amps and the resistance. We know the current and resistance on each resistor, so we could just do V equals IR, and I can get 30 volts and 20 volts. Again, all I'm doing here is just using V equals IR. I didn't show any work. I'm actually okay with you not showing any work because your work is on the circuit. I can figure it out. So we have answered a bunch of questions already here. So we know that the current coming from the source is 2 amps, because remember, in series, the current's the same everywhere, which means all of these are 2 amps. The total resistance in series, you should know you're simply adding them up. So 5 ohms plus 15 ohms plus 10 ohms, and you get 30 ohms. Not too tough. You've already taken care of the voltages on the circuit. I'm just rewriting them here. 10 volts, 30 volts, 20 volts. As a side note, if you wanted to get the voltage of the source, you would take the current from the source and multiply it by the total resistance. Well, check that out. We get 2 amps times 30 ohms, and we get 60 volts. That's supposed to be a 0, but I made it a V0, and it's horrible. 60 volts. You should also remember that in series, if you add the voltages, you get the total voltage. And I think you could do this in your head. 10 plus 30 plus 20 is, hey, 60 volts. They're the same. Terrific. Also, another concept. In series, the one with the most resistance is the most powerful. So that would be 15 ohms. Now, what is that power? Question mark. Up to you. You could do P equals IV. You could do P equals I squared R. You could do P equals V squared over R. Whatever you want to do, you have all the values for that resistor right here. So it's totally up to you what you want to use. I usually say use I squared R. because current's the same everywhere in series, but you have current and voltage, so I would just do P equals IV, which is 2 amps times 30 volts, and you get, what do you get? 60 watts. So this is an application of the math and the concepts that have led up to this point through the activities we did online. So this is all the math and concepts for series. All right, and now we're about to do parallel, so I'm about to delete the screen. If you need to pause it, now would be a good time because I'm deleting. All right, let's do parallel. All right, so here's parallel. Just going to draw a pretty simple parallel circuit. One like this, one like this, one like this. And if it's okay with you, we'll use the same values. We use 5 ohms, 15 ohms, and 10 ohms. And let's do the same thing again. Let's put a voltmeter right here. And let's say that voltage is 10 volts again. Why not? So we got a lot of questions to ask. 1, what is the total resistance of our circuit? 2, what is the voltage on each resistor? V10, V15. What is the current on each resistor? So I5, I10, I15. What is the voltage of the source? What is the current coming from the source? Did I miss anything? 6, what else? I want to know most powerful resistor. And finally, what is that power? So basically calculate it. All right. Well, before we even start hitting up some of these numbered questions, let's start applying some of the concepts we know. In parallel, you should know the voltage is the same everywhere. So if the 5 ohm resistor has 10 volts, then so does the 15, and so does the 10. From here, again, we're just using V equals IR, we're using Ohm's law. Well, we have V and R. We can get that the amps here is 2 amps. Here it would be 10 divided by 15, which is 0.67 amps. And here, 10 divided by 10, tough math, 1 amp. So basically figured everything out. You could also, well, no, we'll skip that. We can now find the total resistance of our circuit, which would be 1 over 5 plus 1 over 15 plus 1 over 10. And unfortunately, I don't have a calculator on me. How funny. So give me a second and you could be mad at me later. But this is 1 over, oh boy, sorry about that. So this would be 6/30 plus 2/30 plus 3/30. Is that right? So it gives us what, 11/30? Who made up these numbers? So that's 1 over 11/30, or 30 over 11 ohms, which, I'm sorry, I can't leave it as a fraction because it's going to drive me nuts. I do have my phone on me. 2.73. 2.73 ohms. So that's total resistance of the circuit. We have already figured out that each of these has a voltage of 10 volts. We have the current on each, which is 2 amps, 0.67 amps, and 1 amp. The voltage of the source, isn't it the same as the other resistors? Because in parallel, that's what we saw in the previous activity. So this is 10 volts. I source. Okay, 2 ways to get this. We could do I source equals V source over R equivalent, which would be 10 volts over 2.73 ohms, which equals Hold on a second. 10 divided by 2.73, 3.66 amps. Also, one of the other concepts that we got from the lab was that if you add, that's supposed to be one of those little birdie things. If you add all the currents, you should get the total current. So if you add these up, you get 3.67 amps, which is the same. Now, in parallel, the most powerful resistor is the one with the least resistance. So it's the 5 ohms. And again, you could do P equals IV. You could do P equals I squared over R. You could do P equals V squared over R. And I usually use this one for parallel because it really shows you that the less resistance when voltage is the same, there's more power. But we have everything we need there. I mean, I would just do I times V. So that's just 2 amps times 10 volts gives you 20 watts. So that's a basic series and a basic parallel. The questions in the homework are very similar to this. And again, if you have any questions, please do not hesitate to ask through email or stopping in during the evening to do a Google Meet and just talk face to face. So again, hope all is well. Take care.